about the difference in how those occur. So what time along the action potential they actually occur. So action potentials can only increase in frequency. That's an important thing to point out. We said that they cannot change in duration, they cannot change in intensity, they cannot change in amplitude. The only thing we can do to sort of ramp up or increase the action potential is increase the frequency. So how fast we fire those action potentials. That's going to be very important as we look at other systems, muscles, the heart. Okay, the way that the nervous system and the muscles observes an increased stimulus is by increasing the frequency of the action potentials. So not the intensity or not the amplitude. And as a result, we have absolute and relative refractory period. So the absolute refractory period is during the course of the actual action potential, right? And ending off at repolarization. So during this phase, because the inactivation gates are closed, here, right? The inactivation of sodium channels, we cannot fire another action potential while this process is occurring, right? Also, immediately after we fire this action potential, right, as we're still repolarizing the membrane, as we're still bringing the membrane back to resting, so this would be depolarization, we cannot fire another action potential here unless there's a very strong stimulus. So physically we could, right, it's not absolute, we could, but there would need to be a very strong stimulus to overcome this negative membrane potential. So this is much more negative than -70, right? Well, not much more, but it's not -70. It's more negative than -70. And so basically we need a stronger stimulus to overcome this membrane potential difference and then eventually get to -55. It's going to need to be a very, a stronger stimulus to do this than if the membrane were at rest, right? So absolute is going to be during the action potential. We spoke about the reason for absolute, right? The inactivation gates on the sodium channel. And then relative is because of the potassium channels. So as I mentioned here, this hyperpolarization is because those potassium channels are still in the process of closing. And so we still have that positive charge leaving the cell, right? Voltage-gated potassium channels are closing. Inside the cell is very negative. It's going to be very hard to get to threshold from that, right? And that is the reason behind the relative refractory period. And this ensures that each action potential looks the same, is all or none, and remains separate, different events, okay? And again, pointing out how we can generate an increased stimulus. We don't increase the time of the action potential, we increase the frequency. All right, so looking more closely at the absolute, right? And we spoke about the reason. The reason was the sodium gates inactivation channel being closed here. And so we cannot physically, even if we tried, depolarize this membrane again. Even if there were graded stimuli, we would not. And so looking at this graph, which looks at the sodium channels against time, we see that the sodium channels are inactivated here, but there are still a few of the channels closing as we get over into the absolute, into the relative refractory period, as well as potassium channels opening, closing as well here. All right, so we have those two events taking place, and so until they fully take place, the membrane is not back to rest, and we cannot fire another action potential. Looking at the relative refractory period, it's going to be the last part of repolarization and spanning over into the hyperpolarization, right, which we looked at on the previous slide. And so here we have some sodium gates closed, whereas some are inactivated. And just to explain what that means a bit, some gates are closed in that only the activation gate is closed, right? They're not inactivated because the inactivation gate isn't closed. But majority of the gates are inactivated in that the inactivation gate is also closed. So this is a process that's gradually occurring. Most of the gates have closed. A few are still closing, and that's because their inactivation gates are closing as the membrane gets back to rest. All right, so there are a few things that are happening here that are overlapping that's responsible for it being so difficult to generate another action potential. The inactivation gates are closing on sodium channels, and the potassium channels are closing.